Hi, and welcome to today's little quickie video. Today we're going to be looking at two things. First, we're going to be answering Simon's question. Then we're going to revisit the Emma's angle video, which was our last little quickie. Now, Simon's question had to do with refinishing some graduated collars that are on a lathe that he is trying to rebuild. Now, as you can see on these pictures, the graduated collars are in a very poor state and they need a lot of work. So let's go take a look at that. Sorry. There. Now, the whole man of steel thing, it's supposed to be a secret. So let's just keep this between ourselves. Let's go take a look at Simon's question. Simon's graduated collar has 125 divisions on it. And that's a problem because my spin indexer here can't do that number of divisions. So we'll just imagine, this is not real, that this is a proper indexing head with a 40:1 ratio, worm to gear ratio. What does that mean? Well, 40 turns of the imaginary hand wheel here will give one rotation of my part. Now, I want 125 divisions, and the formula for a 40:1 indexing head is 40 over number of divisions that we do not resolve on a calculator, that we resolve by simplifying the fraction. That's a must if you want this to work and don't want to go crazy. So I simplify 40 125ths and I end up with a workable fraction of 8/25. 8/25. So I'm going to get an indexing plate of 25 holes, and 8/25 means that every 8 holes on a 25 hole indexing plate will give me one division on my part. Now, this may seem like a foreign language to you if you don't already know how to use a dividing head. Not a spin indexer, our imaginary dividing head. Well, we already have a video on that, and you can go and learn how to calculate your indexing plates and movements for different numbers of divisions. So here's a link to that. We'll get back to this here. Now, I have to line up what I have here as far as tooling. Now, the graduated collar that I've removed from my Atlas lathe here, well, is not hardened. So it's actually quite soft, it's just mild steel. So it's going to be easy to engrave because I don't even have to have a rotary tool here. I can just basically scribe the new lines in. Now, looking at the condition of Simon's graduated collars, well, I'm guessing that his aren't hardened either. So this is probably the way you want to do it. But if it were a little harder, it's not going to be tool steel, but let's say it was a medium carbon hardened steel, well, you might want to use a carbide engraving end mill, a pointed engraving end mill, but carbide, to do what we're doing here. Now, what we're going to do here is first we're going to come and touch the part just to make sure that when I line this up that I'm really on one of the existing lines and our imaginary dividing head has been zeroed up and the backlash has been removed, so we're ready to go. We're just going to come and touch off to make sure that we're above one of the existing lines, and then we'll scribe or lay out that line, which will become de facto at the same time the line on our graduated collar. And then we would, if we could, index for the next, do the same, index for the next, do the same. But once I have my depth set, I don't have to touch off every time. Really just the first one so that I know where I am. So let's come in a little closer and take a look at that. Little polishing, deburring, and there we have it. A nice new graduation. Well, that worked great, but there is something that I would change about the setup that we just saw. First, well, I'm only doing one line here, so I did a quick setup and I set up my 1/4" dowel pin that I'd sharpened to a point in the drill chuck, and that's a bit of a no-no. So had I been doing this on a grander scale, well, I would have used a collet to hold the dowel pin, and that would have stiffened everything up and made it work even better. That being said, not everyone has a dividing head that they can use for a job like this. And as I said, my spin index couldn't do the 125 divisions required. So is there another option? Yes, there is. We can use a chisel punch to spruce up the marks on the graduated collar, but it's going to require a lot of attention to detail. If you had a choice, I would choose the first method, but if you're ready to put some time into it and do it very carefully, well, this could work. So let's take a look at that. So what I've done here is I've aligned my tool post with my cross slide, so that's nice and parallel. And then I've mounted this finger clamp on the tool post base and indicated it as well as nice and straight. And that's going to give me a rest, that I'm going to be able to rest this large cutting tool onto. So there you go, and I've already figured this out as far as my distances go, and I'm using this toolmaker's clamp as a secondary rest. So I have a rest here for a tool and a rest there for a tool, and note that it does not stop the rotary motion of my scale. And now, by aligning with the edge of this rest, align on my scale, I can come with this punch. Now look, this is a tool for a lathe tool bit, and I've got it down to a very sharp point with a very short edge on one side and a very long edge on the other that I'm going to come and lean up onto my two rests, and then using the brass end of a positioning hammer, and this is important because this is tool steel. We do not want to hit tool steel with tool steel, so use a brass punch or a brass hammer, and I can come in, punch a mark. And that will provide the basis for the marks that I want to produce. I can then bring the graduated collar over to the bench, set it up in the vise, and finish with a proper chisel. So basically this setup gives you some control over what you're doing. It positions the punch before you strike, but you still have to be very attentive to what you're doing. But this won't help Simon for the graduated collar that has no marks on it whatsoever, because what I've just done, well, is aligning on existing lines and just making them a little more visible. So what could Simon do for that? Well, same technique, same setup, but we're going to add a dial indicator on the axis that I'm trying to repair so that I can see 1/1000th of an inch increments. And in my case here, each line on my graduated collar is equal to 1/1000th of an inch. So that's what I'm going to do here. So let's take a look at that. So I have my dial indicator nice and straight, parallel to the axis of my tool post and of my cross slide. So it's important that it be nice and parallel. So that being set up, I'm going to place, taking care of the backlash, place myself on a division, and with my cross line I'm going to come and position my dial indicator on 0. I can now get my punch, lean it up onto my 2 stops, and punch that hole, not the hole, punch that line. Now I'm on 0, so all I have to do now, I don't want to use the cross line, but in the direction that I took up my play with, I'm going to move 1/1000th of an inch, get my punch, set myself up again, start over, and so on and so forth. For Simon, since he needs 125 divisions, well, he's going to do this 123 more times. One thing that I should have mentioned is that we want everything to be tight. Our cross slide axis and our compound rest axis have to be able to move, but they should be quite snug. I don't want things moving around on their own when I punch. And really remember to take up your backlash on your first division so that it doesn't come back to haunt you later on. Now, I've punched 4 lines here. I'm going to head over and just finish them up, and then we can take a look at the result. Well, those marks that I've just produced, well, they are quite light. We don't want to hit very hard when this is mounted on the lead screw of the machine. We don't want to damage anything. So we've just made light guide marks, really. So now what we want to do is position our part in our bench vise and tighten it down well, using aluminum soft jaws because, again, I don't want to damage my part here. And then with a very sharp small chisel and, again, my small hammer, well, we're going to come in, make those marks a little deeper. After which, we'll get our number punches out and just make our numbers a little more visible as well. After that, we're going to get a needle file out and very delicately come and remove the mushrooming caused by the punching. Now the mushrooming on the end of the part, because the lines go right to the end, on the side there's a bit of a mushroom that's produced, and on the diameter of the part. And once that is done, well, we'll head back to the machine and polish the graduated collar, but not with a very fine grit emery cloth. We're going to use something with a medium grit. We want this to have a brushed metal look, because if it's too polished, the lines will be hard to see. So let's take a look at that. So there, I got everything reassembled, And here's our new lines. Well, that worked out pretty good. But really, this second technique is pretty involved. And it's something I came up with really just to help Simon out. Because most people don't have access to a proper dividing head in their home shop. But if you do have access, or if you can borrow one, really the first technique on the mill with a engraving tool or with a rigid scribing tool with a proper dividing head, really that would be by far the easiest and best way to go about it. So Simon, I hope this helped. Now, I've received a few comments about my last little quickie about Emma's angle, and there's something that I think that needs to be explained a little further. So let's take a look at that. Well, thank God for being lazy, because I haven't gotten around to erasing the whiteboard yet while I still have the sketch, so I can carry on with that explanation. Now, a lot of people mentioned in the comments, well, this really won't work because what you want to do is do the same thing twice and that'll give you your angle and all that stuff. But that wasn't what we were measuring here. Really, all we wanted to know here was if this surface angle, angular surface I should say, is it at its proper distance in relation to its reference surface back there. When we're doing this, well, we are already supposing, or we know already, that we have the proper angle and that that surface is nice and flat. If we don't have that, well, this won't work. Well, why would we do this if this doesn't give us our angle? It's important to remember that an angle, well, is the result of a flat surface at an angular distance from a flat surface. In other words, angular measurements, especially when it comes to geometric tolerancing, well, are related entities. You cannot have an angle if you don't have two surfaces. That being said, the angular surface is also dependent on how flat it is. Now, some people confuse flatness and angularity, but in reality, an angular surface has to be flat within a certain tolerance. And once we know that it's flat within a certain tolerance and that its reference surface is flat within a certain tolerance, well, we can then measure the angle. But we have to divide and conquer because we don't live on a whiteboard, we live in the real world. And that means that I cannot just magically poof, mill a flat surface at an angle at the right distance all in one shot. There's really no practical way of doing that. Somewhere down the road I have to start to measure things. So what do I do? Well, I divide and conquer. The angle that we obtain in a setup like this, if we were milling the angle, well, the angle has to do with your setup. And the flatness of the surface of that angle has to do with your setup. So when you set the part up on the mill at an angle or incline the head of the mill, well, you get those two entities within what you need as far as tolerance goes. But the only thing that doesn't have to do with setup here is the distance that separates that surface from the reference surface, your angle from the reference. And that's why we divide and conquer. We carefully set up to get flat and angle. We measure that to know that yes, the part is flat and yes, it is at the proper angle. And then we progressively remove material to get the third requirement, which is the distance between the two. So I hope that clarifies things. There's one thing that I think would be good to mention, and that is that geometric tolerances exist, and maybe you've never heard about them. So for angles and flatness, well, it's good to look into geometric tolerancing, and here's a video that might help you on that subject. So I hope that clarifies things here. in the shop, we're always dividing in order to conquer. So that's the end of this first little quickie of our new season. I hope that you found it enjoyable, and to everyone out there, as usual, have fun. Be safe. Very important. And happy machining.
So all I ever wanted was a little monkey from you.